Okay, great. So, hey everyone, my name's Octavia, and I'm a principal security engineer here at Prelude. I'm also the community manager. So every week we're hosting talks in our Discord. We're inviting guests to come out and speak about something InfoSec related or even InfoSec adjacent. And in particular, we have a focus on providing training and mentorship to new speakers. So we're looking for new and first-time speakers to come out that might not have done a talk before. If that sounds interesting to you, I'd love to hear from you. Today we have a really special guest, Cas van Cooten. I hope I got your name right. I've only read it. I don't think I've.
Yeah,
Okay.
all good.
Speaking about NimPlant, which is an open source C2 framework written in Nim, a language I love personally. So yeah, with that, I'll pass it over to you and take it from here.
Yeah, thank you very much, and thanks for having me as well on this nice day. At least here in the Netherlands, we even had some sun, which is, as you know, rare. So hi everyone. Thanks for tuning in. My name is Cas van Cooten. I'm a red teamer based in the Netherlands. And today I will be talking a little bit about both a tool I recently released, which is NimPlant, as well as malware development and malware development in the Nim programming language in general. A little bit about me. As I mentioned, Cas van Cooten, based in the Netherlands. By day, I'm a red teamer at a big bank here in the Netherlands, and kind of by night or more by afternoon. I like working on anything that makes my job easier. And in that capacity, I kind of rolled into malware development. Good to know that I don't have a very technical background or even a technical background at all. I initially started in information science, which is a very business type, computer science-ish study. So I really rolled into it when I got started. But I really like it. Malware development, I think, is a very important capability for any offensive team. And it's also a lot of fun to do, right? It's like programming, but programming to both support your work and to make computers do stuff that they shouldn't normally do. So it's a really cool area of our job, I think. So it kind of rolled into that. And also was inspired by Marcello Salvati, I believe it is, Bytebleeder. You may know him by his Twitter handle. He published the offensive Nim repository at some point, and he kind of inspired me to look at Nim as a programming language for malware development. Why I stuck with it, we will go over in a couple of slides, and afterwards we will be talking about NimPlant mostly. Up front, I see there's quite a bunch of people watching live, which is awesome. Let's try to make it an interactive session as much as possible. I have the chat here on my screen, so if at any point you have questions or comments or remarks or just want to laugh at me for not using C or C++, feel free. Otherwise, of course, at the end there will be room for questions. But let's try to keep it interactive. I always like it that way. If at some point after the talk you want to get in touch or look at my tools or past presentations, whatever, I have my social media here, mostly active on Twitter, where it's about 80% memes and shit posting and 20% actual content. So if you're down for that, give me a follow. And also very responsive to DMs if you have any questions. So with that out of the way, a little bit of a recap. Why do malware development in general? This is something I also spoke about at the ZEVCon in Poland last year. And I already mentioned it a little bit, right? As offensive security specialists, our job is shifting from just testing controls to really staying ahead of the curve in terms of being able to even bypass basic controls, because the basic controls are getting better every day, right? And that means that your run-of-the-mill offensive security tools that you just grab from GitHub and compile and try to run, that's not going to cut it anymore. So offensive security development and malware development as a kind of subset of that, I think, are becoming increasingly important in our job, especially as a red teamer. You even have the kind of field of red team engineering, which you can really fill a full-time job with just building tools to support offensive operations, right? But even outside of that, in pen testing, broader offensive security operations, I think having the kind of know-how on how to develop your own tools, or at least how to tweak public tools to get them to do what you want, that's really a vital skill, and it's becoming increasingly more important. So yeah, I think everyone, be it red or blue, should have some know-how on how to tweak tools to get past defenses. And of course, for the blue side, how to keep an eye open for the modifications that are made, and how to detect those as well. Of course, today we're talking about Nim, and Nim, I think, is part of a larger trend that we see in the past couple of years, where threat actors, so that's both the real threat actors as well as red teamers and legitimate offensive security specialists, they are kind of moving towards newer languages. And when I say newer, I mean, in the past 10 years or so. Nim is an example of that, but also languages like Golang and Rust, I think, are good examples of younger languages that are used and abused for malware development. There's a couple of reasons why new languages are especially interesting. A big part of that is, especially at the kind of inception of new languages, the defensive specialists, they don't really know what binaries compiled in those languages look like. So, for example, with Go, and I think Rust as well, they have like this virtual virtual machine runtime that's supporting the language, which makes it so that the binary that you generate is entirely different from a standard classical C or C++ binary, right? So that's a nice incentive for the initial inception of a language. And after that, there's actually a lot of reasons why a certain language could be interesting. Most of which I think is preference and community, right? There's a lot of reasons not to like C or C++. In my experience, as I mentioned, my background is not very technical, right? I never studied for programming or anything like that. And that makes it so that I really don't like writing programs in C or C++. So having a language that kind of helps me in that regard, kind of has fail-safes for the common mistakes, and still allows you to do the same in an operationally secure way. That's a really big advantage. So personally, for me, I like Nim. Of course, as I mentioned, it's entirely up to preference, right? I'm definitely not saying C or C++ is a bad choice for malware development. The opposite, I think they are still mostly C, because it's the most low-level language, besides assembly, of course. Is actually the arguably the best choice, because it gives you the most control. But of course, your quality of life is also worth something. So that being said, everyone should have their own pick, and of course be conscious of the ups and downs of a certain language. That all being said, today we're talking about Nim. So I'm going to give a couple of reasons why Nim is awesome for malware development. One of those is the flexibility in terms of what you can compile. By default, Nim actually transpiles to native C, which means that the compiler basically translates your Nim code to a large blob of C code, and then compiles that with a regular compiler like GCC or Minimal GNU for Windows to a native binary. Excuse me. But Nim also gives you a lot of other options. So you can compile to C++, Objective-C for Mac, very interesting, or even JavaScript. So yeah, it gives you a lot of flexibility, and also in terms of the platform, yeah, you have a lot of I see a question, is Nim getting picked on by antivirus just for being Nim? Last time I wrote anything in Nim, antivirus alerted on it for including Winim, and I wasn't even doing anything malicious. I'll park that for slides I have a bit later, but definitely good question. But continuing on the reasons for Nim, another reason, a bit of a smaller one, but definitely interesting, is that it doesn't rely on a runtime. As I mentioned, Go is a bit notorious for this, right? That if you, I think if you even just write hello world, already the binary is 4 megabytes. I think in the era of yeah, gigabit internet and yeah, high quality connections, it's not that much of a problem anymore. But still, yeah, the flexibility of having very small binaries that you can just convert into shellcode, for example, without issues, is quite nice. One that is really a big pro for me is the Python-inspired syntax. I really like Python, not for on-target operations, I would say, but yeah, Python is just a very nice language in terms of how naturally it writes. It's almost like just typing English, and the programs just work. TM. So having a lower level language that has a similar syntax is quite nice. And on top of that, it, yeah, as I mentioned, I don't really like writing C, right? But there's also a reason not to write C, which is that it's really easy to introduce unsafe code. So either, yeah, having you crash your binaries, or even worse, introduce vulnerabilities in your own code. Is not nice. So Nim kind of helps protect against that, while not sacrificing the low level capabilities. Another one is the foreign function interface. I think this is actually quite important for a language to have if you want to write malware in it. FFI basically means that you can easily interface with things like the .NET runtime, right, the CLR, or interfacing with native C, and yeah, I think most interestingly, the Windows operating system itself. Nim is really mature in that. I think most languages nowadays have libraries that provide this, so it's not too much of a worry. But yeah, definitely one checkbox ticked. And finally, I think also ties into the first point. It's really easy to cross-compile programs in Nim. In my case, I usually write programs targeting Windows. Of course, it's also possible to have cross-platform programs or write macOS malware, for example. But on the other hand, it's also easy to develop on Linux and compile towards Windows, for example. That's all no problem. Yeah, because of that, both the flexibility of the compiler and of the language itself. So now we get into the question that I just saw in the chat. Is why is Nim always getting flagged by antivirus? This is a known trend, and I think ties in closely with the fact that the language is so small. Actually, especially for Nim, nowadays I think a large part, I don't have a percentage or something, but I would say maybe even towards 50% of the users of the language are malware developers. Because it works really well for that, and the adoption in terms of legitimate development is relatively small. So that gives a weird conundrum where antivirus yeah, the vendors are basically just signaturing the language itself, which makes it so that if you are unlucky and you write a hello world, which is also what happened with an older version in the left screenshot, you write and compile a hello world, it will already be flagged by antivirus because it simply is written in Nim, right? It's really, yeah, weird, and in my opinion, a bit of lazy signaturing by AV vendors going on there. But it's also, yeah, a problem as a malware author. Luckily, most of these signatures seem to be really, yeah, basic. So I think most of the detection that happens in these cases is based on the standard imports of the Nim library. For example, if you look in the binary, you will see strings such as fatal.nim and a couple of other, I think, standard libraries that are imported. If you import Winim, which is the case that was mentioned in the chat, it also adds a manifest file by default. If you kind of look and understand what these detections are based on, that means you can also easily bypass them, right? So Nim is definitely still useful for malware development. If you're just getting started, do not get thrown off by the fact that the binaries are flagged, even your hello world is flagged. This is doable to get around. I do understand that for both legitimate developers as well as malware developers, this can be a bit of a turnoff, right? Especially when you're just getting started. But know that this is not a problem in practice when you get the hang of it. So looking at a bit of the Nim syntax, I don't want to spend too much time on this because we also have the practical part with NimPlant. But yeah, I think this code snippet, which is from Rosetta Code, essentially makes a web request, base64 encodes it and prints it out, truncated if it's longer than 64 characters. Not too interesting malware-wise, but I think this really shows how Python-like Nim is in practice. You can see the import statements, right? At the top, in this case, both are, I think, from the standard library. Nim has quite an extensive standard library, of course, all documented as well, so quite flexible in that regard. You can see things like string concatenation, subranges, the indentation in logic statements, which is also very Python-like, so no curly brackets for your functions, stuff like that. It's all indentation, spaces or tabs, doesn't matter, but pick one. And I think one thing that you can't really see on this screenshot, but that is very important, is that Nim is strongly typed. So types of a certain variable cannot change. But as you can see on this code snippet, types can be inferred, right? So if you create a new HTTP client, that means that that variable will be an HTTP client forever, but you don't really have to explicitly say it. Some exceptions, of course, but I think, yeah, for simple code, you don't really need to worry about typing. Of course, the upside of typing is that when you're programming, your IDE already knows if you're making mistakes with typecasting or accessing properties, things like that. So I really like the fact that it's strongly typed, but the type inference also makes it really easy to write your code. A little bit more relevant to malware development is we start looking at the Windows API. On this code snippet, you kind of see how that works, right? So small primer for the people not familiar with malware development. Windows has an API that you can access to basically, interact with the operating system. This is something you do all the time as either a legitimate developer or malware developer, it doesn't matter. But especially, when starting out in malware development, I think Windows API is one of the first themes that you will touch upon. And in languages such as .NET or C#, you have the concept called pinvoke. And what you see on the screen here is kind of the Nim equivalent of that. So what we're doing here is basically first defining some types of the that the Windows API uses. And then we're defining the proc, which is a function in Nim message box, which we essentially import from the Windows API. In this case, the user32 library. And after that, we call it with certain parameters. So if we would run this code, we will get a nice alert box pop up. What's notable here is that Nim, if you use the Windows API like this, Nim uses the dynlib library by default. And what that means is that essentially your imports will be resolved when your code runs. So that means that if you look at this binary statically, you won't see the user 32 import in this case. Only when you run it, it will be resolved and the message box will pop. This is something that we call de-invoke or dynamic invocation in malware development. And it's really good to know that if you get started with Nim, that this is kind of the default behavior, right? I think maybe also part of the reason why antivirus vendors are suspicious of Nim binaries by default, because this is if you interoperate with the Windows API, this is just how it works. And of course, we're lazy. We want to use libraries, and I think Winim is one of the biggest libraries that you would use as a malware developer. It's basically the library for Windows operations. There's a couple of subsets of it, so you can use the lean one to have a bit less imports. It has full component object model support as well. It allows for a lot of interoperability, and I think NimPlant also makes happy use of this. So if you would use, if you would not cast the functions yourself, you can just import Winim, and in this case, pop the message box in this way, which is of course really nice. One last code snippet that I want to walk through before we get into the NimPlant demo is this one, because I think it showcases some more advanced functionality of Nim, but still, shows how elegant it is to write. Because in this case, we're looking at Strand C, which is a port of, I think it's a C or C++ library. Originally, someone ported it to Nim. And basically, what this does is it obfuscates static strings at compile time. So if you write the string "Hello World," bet you can find this. Just imagine that that's a very suspicious string where you say something like shellcode executed. You don't want that string shellcode executed to be present in your binary, right? So what you can do is, for example, do a simple XOR on that string and at runtime decode it and run it. But of course, when you're writing code, you don't want to have strings obfuscated for you when you're writing them. So what this library does is essentially it defines what is called a compile time macro, which replaces, when you press the compile button, it replaces all strings with this function that you defined by default. It's XOR, and it does so transparently. So in this case, you only have to import the Strand C library, which you can install with the Nimble package manager if you don't have it. And basically, the output of that will be what you see at the right screenshot, which is that obfuscation function that we defined. You can see that the string completely disappeared. Of course, this is not bulletproof obfuscation, right? A reverse engineer will make short work of this, but it at least means that the antivirus engines or even the EDR engines looking at the binary will not arbitrarily be able to see the string, which is kind of what we're going for here. Another nice thing is that it uses a base key derived from the compile date and time. So this also introduces some non-determinism in your binary, basically meaning that every time you generate a new binary, the hash will be different, right? And that's also for really basic hash detections. That's really powerful as well. I would recommend if you use Strand C in your projects to modify it a little bit. I also have a screenshot of the full code. This is actually it, right? This is the entire code that defines this compile time macro and make sure all your strings are obfuscated. I would recommend to tweak that a bit, especially the function name, the obfuscation logic, things like that. But overall, quite elegant bit of code to obfuscate your static strings. I'm not going to go into the details of this because I want to get to the practical part. As I mentioned at the start, one of my first projects when I got started with Nim was actually NimPlant. And I initially started it as kind of a project to learn more about the language Nim, right? And also learn more about malware development in general. And it kind of grew out to be a yeah, I would even dare say a usable command and control framework, or rather, it's more of a first stage command and control implant, right? What I mean by first stage is that that NimPlant was designed to be used early on in operations. So let's say you fish the target, you would deploy NimPlant on their machine, just as a lightweight payload, a kind of under the radar type payload. You could also use NimPlant to persist on a machine, and then whenever you need it, you can use NimPlant to step up and deploy I don't know, Cobalt Strike or a Sliver, whatever you want in memory, to do the more heavy lifting of the operation. That's what it was designed for. I should say that over the course of time, also, in the interest of it being a nice project to work on, it grew out to be a bit more than that. Because there's BOF support, there's all kinds of execution methods, inline execution of .NET assemblies, things like that, which are I would say quite risky for a first stage implant, but definitely nice to have. Kind of side project that I did was the web interface as well, which I'm quite proud of where I got it, because I had like zero pre-experience in front-end development, but it actually works really well. Can also be used if you have multiple operators interfacing with the implant, right? So that's nice as well. Of course, there's basic configurations that you can do for evasion, for the C2 behaviors. It is HTTP or HTTPS only at this stage, but should be quite extensible if you want to introduce other transportation methods as well. So that being said, let's jump into my VM and see what that is all about. I think you can see my VM now, right? Yeah, at least I can see my VM. Let me know if you don't see something. So in NimPlant recently open sourced. You can find it on GitHub. On my GitHub, NimPlant. I think if you Google for it, it finally bypassed the legacy Mythic implant, which was also called NimPlant. Very unoriginal name. You can see in the README, I tried to document it reasonably well. Writing documentation is always less fun than coding, of course, but all the instructions should be here for getting started and compiling the implants, setting up the infrastructure, and so on. Interesting to note that there's also a Nim-built Docker container that you can use. If you don't want to have the dependencies on your system, and especially if you're cross-compiling, installing the right version of Nim, the right version of Minimal GNU for Windows, all the libraries that are used by NimPlant can be a bit of a pain. So I maintain this Docker container to easily allow for the right dependencies to be used. But all the installation instructions are also here at the top. There are a couple of OPSEC tips and tricks as well in this documentation, and of course usage instructions. I think for now that's not too interesting because we can just walk through the usage. If you have any requests on what you would like to see, or maybe some recommendations on usage, feel free to shoot them in the chat. Happy to have a discussion about that. So here I have a fresh NimPlant repository. If we just run the wrapper script, which basically takes care of everything, it will tell us that there's no configuration file found because we need to initialize one. There's an example configuration, so we can just copy that to a file called config.toml to get our own copy, which NimPlant will read from. And let me open that up in Visual Studio Code so it's a bit easier. Worth noting that this configuration file is actually shared between both the C2 server and the C2 implant, which means that if you configure certain settings, for example, let's say the command and control paths, they will be baked into the implant that you deploy on the target, but they will also be read by the server. That means that if you separate the process of compiling your implants and running the server, you need to make sure that these configuration entries match, right? Otherwise, the server is not gonna be able to communicate with the NimPlant, or the other way around rather. So that's important. Also important is that on first compilation, a unique XOR key will be generated for pre-cryptographic operations like the key exchange and stuff. So that file also needs to match if you have a different compilation machine from a server machine. If you run everything on the same server, should be yeah, you don't need to do anything basically. So let's quickly go through these settings. So there's not too much here. It's fairly straightforward. Try to keep it minimal. First, we have a section on the API server and GUI. So this is the operator side of things. So we definitely recommend not to touch this IP, right? You can expose it publicly if you change this to quad zeros. But if you do so, be really cautious because NimPlant does not by default enforce authentication on the graphical user interface. So normally I would just keep this localhost and SSH port forward or whatever you want to actually reach that interface. But if you expose this to the internet, for example, everyone can just get to your server. So if you want to expose it in any way, would recommend to put it behind a reverse proxy that does support authentication, for example. Second block is about the listener. So this is basically what defines the command and control traffic. As mentioned, by default we support HTTP or HTTPS. If you want to go the HTTPS route, you can define a certificate and key for SSL. If you have Let's Encrypt, for example, you can use those certificates and keys for your domain. Would always recommend to put NimPlant behind a redirector for several reasons. So that means that these settings don't matter all that much because your actual NimPlant listener shouldn't also not be exposed to the world. But for quick testing and stuff, this is all fine. Of course, we also define our host name and IP address. If there is no host name specified, it will use our IP. So in this case, we do have to specify an IP that we will be reaching out to. In this case, I'll keep it localhost because I'm just demoing everything on the same machine. But in a real operation, you would keep this quad zero and just have your malicious site domain here. And that will mean that the server is listening on all interfaces, but the NimPlant will be calling back to this IP address. Finally, we have the path. This is basically by default what NimPlant will use to communicate with the server, right? There's 3 atomic operations that the NimPlant will do. The task one will be most prominent because that's the check-in that it does. This is the endpoint that it will post results to, and of course there's as I mentioned, the key exchange and registration as well. So definitely change these because this may stand out. Sorry, I have a bit of an itchy throat. Let me grab some water. Don't see any questions yet, so if you have questions, let me know. And the final section is the actual implant side of the configuration. So we can see a couple of settings here. Some straightforward ones like the default sleep time and jitter. We have a kill date and the user agent that the implant will reach out to the server. But we also have some more interesting settings. I think one interesting one, especially if you want to use NimPlant for its original purpose, which is a early stage implant, this risky mode is interesting because you can disable this mode, which will disallow access to any OPSEC dangerous commands, basically. But that also means that they won't be compiled into the implant at all. So if you want to have a low chance of detection, this is actually recommended to disable. But of course, that severely limits the capabilities of the implant as well. By default, it's true in most cases. About 80%, I would say, keep it on true. But of course, for any dangerous command, do keep in mind what you're actually running, right? Because if you run shell who am I, that's always a bad idea because it spawns a child process, stuff like that. So as with any tool, the operator should be aware of what they're doing. And yeah, this is kind of a fail-safe to keep that functionality out of the implant altogether. Then there's another interesting option that currently only supports standard executable binaries. But this is the sleep mask. I see Fabian is actually in the audience right now. So thanks for this, PR. What this does is essentially, it doesn't call sleep for the implant to sleep, but it basically sets up a certain trick, not important what it is, for the implant to encrypt itself when it's waiting for a new command. So this makes it so that if you have a sleep time of 30 seconds, for example, NimPlant will be encrypted in memory during that time, and when the time comes to check for a new command, essentially it will decrypt itself and check that command, run the results or post the results if applicable, and repeat the same again. So this is really good against in-memory scanners. Normally, I would not really do this from the from NimPlant itself. You can also hook sleep, for example, with your loader and have a custom algorithm. Or of course, you can modify the echo class, which is here to have your custom logic. But for convenience, it's a nice feature to have. So that's it for the config. I think this configuration is fine for us for now. Let's lower the sleep a little bit. This is the default sleep, so you can of course lower it at every runtime as well. So once we're happy with our configuration, what we can do is we can use the same wrapper binary to compile our artifacts. NimPlant supports a couple of binary artifacts that you can use. I think the executable one is the most straightforward one, right? It's just a windows.exe. There's a .exe that actually deletes itself when you run it, which makes it so that after running it, it will be completely in memory. Then you have the library, the DLL file. Usually a bit more evasive than executable binary executables for some reason. Basically the same thing, you just load them in a different way. This also allows you to side load, for example, NimPlant into other processes. And finally, we have the raw shellcode. NimPlant uses shellcode reflective DLL injection, or the SRDI, kind of well-known trick to get this DLL to be reflective in memory and also position independent. So that means basically that you can load it at any point in a process to get NimPlant to execute. So I think in operations, this is most typically the option you would use. Also, if you have your own shellcode loaders, for example, packers. Fabian last week, of course, talked about this in depth. So this is what you would use that with, so that you have your own layer of encryption, obfuscation, sandbox evasion. All these things are not implemented by NimPlant, right? So you can implement them yourself if you use a packer for that. So typically you would use that. So we have our artifacts stored in the bin folder, and once we are at that point, we can simply use the same script and say that we want to run a server. As you can see, this will start 2 listeners. So we have the actual the web user interface, which is on localhost port 31337 by default. And we have the listener itself, which is in our case also in localhost. Normally this would be exposed via a redirector or something. So if we go to the web interface, we will see that this is the GUI I was talking about. You can see the basic information about the server, the console messages, everything is here. Of course, we don't have any NimPlants yet, right? So not much to do here, but this is typically what you would use the program with. That being said, it also supports a full console mode. So if I trigger a binary, let's go to the NimPlant directory and just trigger the basic executable, for example. We will see that in the console we get a prompt. Autocomplete command, autocomplete everything you need basically. But of course the web GUI is way more fancy. So we didn't see it now, but this is actually like a real-time interface. So whenever I click on the second executable, it will update and show you the latest information. When we click on the NimPlant, we will be able to interact with it. You can also see that what I just did in the console is of course shared between every interface. So you could have one operator in the console and the rest in the web GUI if you would so desire. There's a bunch of commands. Don't really want to get into all the commands that are here, right? I think most of them are not too interesting in the sense that basically every self-respecting command and control framework will implement these. You do see a couple of utility commands like get the domain, get the local admins, get the installed antivirus. These were implemented because the purpose of NimPlant was to be that first stage framework. But you see a lot more. So if you're interested in this, I would say have a look at the repository. It's all explained there. Of course, every command also has a help. So we can say help inline execute, for example, to get help on the BOF command. And you can do this with any command. You will also note that some commands are denoted with a GUI flag. That basically means that this command will have a GUI modal. So if I type shellcode inject, which is one of the GUI commands, without any arguments, it will pop a modal which basically asks us what we want to inject and where. So actually, let me spawn a notepad just to demonstrate this. And let's go back actually and do it the NimPlant way. Check the processes and get the process ID for Notepad, which is 7616. So we type sh inject without arguments again, and we can say the process ID will be 7616. And for the shellcode, let's actually take the shellcode that we generated with NimPlant itself, right? So this is one of the typical use cases of shellcode injection. In a normal case, you could also implement, for example, Cobalt Strike shellcode or whatever your second stage is. In this case, we're just going to spawn another NimPlant in the context of a Notepad. So you can see that, I can upload the file through the front end and define all the parameters. Quite quickly, we have a low sleep. We will see that this shellcode has been executed in the remote process. And we will also see that we got a new NimPlant, which is now running in the context of Notepad. So this is the basic process migration, remote process injection. That's the basic usage of the shellcode injection. I think a more interesting case of the GUI model is the inline execute command. Which is the command to run beacon object files. Originally, these were designed for Cobalt Strike, of course, but yeah, nowadays with COF loaders, yeah, they have become a lot more prominent. NimPlant, by the way, uses a Nikov, which is a Nim COF loader. So definitely kudos for that, because I couldn't have written this myself. But that being said, we can use this model to basically define everything we want. I do have, let's see, a basic beacon object file here from the Trusted Sec repository. This one will list the firewall rules. It doesn't need arguments, so yeah, we can define as many arguments as we want here, but this one shouldn't need that. So again, we can upload it through the front end, and it will run it on the server. I think a more interesting command is, or interesting case, is using a more complicated BOF. So in this case, we can use one of the remote operations beacon object files, which are also by Trusted Sec, to demonstrate how BOF arguments work. And this one, off the top of my head, will need a process ID, which is a integer, and it will need the shellcode to inject, which is a binary blob. Because binary blobs are, of course, a pain in the behind to paste. I take them either in binary or in base64. So normally you would use base64 for this. I'm going to cheat a little bit and take a example from the README, which is just shellcode for popping calc, if I'm not mistaken. So we can paste that base64 shellcode in here, specify the process ID, which was 7616, if I'm not mistaken. Let me just double check that. 7616, yeah. And I think with these arguments, it should actually work. So you will see it again uploads a file, and we can see that pops calculator. Of course, this is basically the same as what the shellcode injection command is doing, but having beacon object files for this basically means that the framework is infinitely expandable, right? And you can bring your own BOFs to have new injection methods, new operations, and they will actually not be present in the framework itself. They will just be transferred and loaded whenever you need them. So I think this kind of shifts the paradigm of remote operations a little bit, and it's quite nice to have this model to help you, because I see a lot of C2 frameworks that need you to remember all these flags, right? To have the order, all the types of arguments that you can pass to BOFs, and it's just confusing. So this way of operating with modals helped me personally a lot. Of course, it's also interesting or useful when you need to upload files, but you're not located in the server console itself, because normally you would need to SCP it to the C2 server and then specify the upload command. And this just makes it really easy from the web front end. As maybe a last demo, because I see we're already nearing the hour a little bit here. You can see the download screen here. The download screen is actually used for two things. One is for, of course, the download command, which allows you to retrieve remote files to the server. If you do that to a file, it will show up in the downloads view in a downloadable way. But it's also used by the screenshot command, which essentially just takes a screenshot in the context of the target, and also saves it to that download directory. So as a demo, I will just use that command. You will see that it has some metadata about the file that was downloaded, which time, and also which implant you got it from. And you can just click it to pull it to your local machine and have a look at it. So in this case, let's have a look at that screenshot. Makes sense. We took a screenshot of us taking a screenshot, so a bit of a screenshotception. But normally this would, of course, be your target's desktop or something, right? Working on super secret files or something. But yeah, the communication with the GUI is actually goes in two ways. Really allows you to put files to the server when you need it, and also pull them down again without ever needing to SSH to the server if you don't want to. I think that's it for the base demo. We can do two things. We can open it up for discussion, or if there are no questions, I can also walk through the some interesting aspects of the code and maybe some OPSEC tips for using NimPlant. But first, maybe I want to see if there are any questions, requests, or whatever in the people watching.
Yeah, let's open it up for questions. I'm just going to read the back scroll here, see what we've got. So there's a question about antivirus, which I think you answered already.
Yeah.
And in the general chat, there's also a question. Does NimPlant support module stomp?
Module stomping. Was that the question?
Yeah,
Module stomping?
Yeah.
Right. So NimPlant out of the box doesn't do loading methods like that. But yeah, as I kind of touched upon at a certain point, in my opinion, there should be a little bit of separation of concerns between. Oh, there's my screen going off. Separation of concerns between the actual command and control framework itself and the way in which you load the command and control framework. So in other words, I try to stay away from features like module stomping in NimPlant itself, because having all these loading methods and also all the kinds of tricks that Fabian talked about in his talk about Packers last week, maintaining all of those for NimPlant alone will be a pain. And frankly, if you open source it, it will be detected, period. So what I would recommend for more advanced ways of loading the framework, like module stomping, I would recommend to take the NimPlant shellcode and load that in using a packer or loader or whatever you want to call it. So like it's really a stage 0 payload to in this case module stomp onto a trusted process and run it like that. So short answer is no, NimPlant does not support that. Of course, there's a couple of loading and evasion tricks that it does support, such as the string obfuscation, the self-deleting executable, sleep masking. The real boundary between what is the responsibility of the implant and what is the responsibility of the loader is a bit vague. But module stomping I have not implemented, no. So that would be the kind of bring your own module stomping payload type situation.
Got one more question. Does NimPlant have a dark mode? I like light mode. I'm a light mode fan. In fact, I don't know if we have anyone from Prelude on the call, but I'm still waiting on an operator light mode. Just saying.
Oh, it only has dark mode. That's the other way around. No, that's a good point. I actually the shout out to my former colleague Kadir. He did like all the front end design work. He actually created the initial version of the front end in Vue, and I later recreated it entirely in Next.js, which is an awesome framework, by the way. But I stole kind of all his design ideas, which includes the color scheme, and I'm definitely not good with design concepts like this. So I'm a bit scared of tinkering with the color scheme and stuff. I might try it actually. It's a good point. I never thought about it up until now. That a dark mode would actually be nice. But now that it's also the sun is setting here, I definitely see see the point of it. But I know that Next makes it really easy to do, and I use for the people interested in front end development, I use a component framework called Mantine for Nextjs. So with those, it's actually really easy to build interfaces like this one. and also to tweak the color scheme during runtime as compiled JavaScript basically. So I will put it on my to-do list, but no promises because I'm horrible with design work.
Awesome. I think it looks great, actually. I see someone typing in the chat, and we might have one or two more questions. If there's something you wanted to dive into before we run out of time here, by all means, you can poke at the code or whatever
Yeah.
while we wait.
Yeah, we can maybe I can provide a sneak preview on which things to modify if you want to use NimPlant in production. Of course, we talked way at the start. We talked about abuse of frameworks, and because I wanted to release NimPlant in a way that was as responsible as possible, I did build in some safeguards essentially for people that don't really look at the code they're using. For them to be easily caught essentially, in the hopes that this would it's not going to stop abuse, of course, but it will help slow attackers down and maybe trip them when they're using NimPlant. So a couple of things to look out for. Of course, change your configuration file. Having a user agent like NimPlant C2 client will be a dead giveaway and will ruin your day. There's a similar one actually in the server. So the server side, I didn't mention that yet. I think I wrote everything in Python just because I'm a lot quicker in Python and it's more mature as a language. And for a server, it doesn't matter that much anyway. So if you dive into the server folder, the utilities folder, and the listener file, this is basically what defines the command and control listener. And it's just Flask, which is a very, very common Python web framework, of course. But if you dive in the definition there, you will see this shady string, and you will see it being decoded at this point and later on also being used as the server header. So this is basically the counterpart of that string here, which says NimPlant C2 client, because this says if you look at the server header of the standard NimPlant server, this says NimPlant C2 server. So definitely get rid of that. Set your own server header, or even better, use a redirector, as I mentioned, because a redirector will just be the most legitimate front you can have for a server. And the nice thing about redirectors is, of course, that you can only redirect certain paths or certain user agents or what have you. So you can have a legitimate website hosted somewhere, and if this user agent matches and the path matches with what you configured for NimPlant, only then you will forward the traffic. So that will basically make your server as inconspicuous as possible. And finally, there's one static string here. The version number is actually, even if you don't compile NimPlant in debug mode, it will be hard-coded, unobfuscated in the binary. So this is something that basically every NimPlant rule looks for. The version number changes, of course, but this will be visible in plain text in the strings. So get rid of this line and the line below it as well, because you don't want that. If you want to really get into customizing NimPlant in a bit more advanced way, there are detection rules included in the repo. There's two Yara rules. You will see if you look at them, kind of the logic of what defensive rules are looking for, right? There's of course rules that are not public that look for much more than this in NimPlant. But for example, here you see a list of strings that are typical for Nim binaries. So if you really want to up your game in evasion, have a look at those rules and kind of turn them around to see if you can bypass them. And of course, test everything, right? Test when you're testing NimPlant, intercept your communications with Wireshark. Look what's happening on the server side, on the implant side, and anything that makes you stand out from normal internet traffic is something that you would want to tweak. That said, it's very doable to use NimPlant in real operations. Before I released it, I actually didn't have to modify it at all before using it against quite mature environments with EDR and antivirus and everything, proxies even installed as well. Yeah, now it's open source. It's a bit harder, but definitely doable. I see another question came in, if NimPlant works in a proxied environment. Yes, this is actually something, it initially worked and then I forgot about testing it and it stopped working at some point. But in 1.1, I did push a fix that makes it so that NimPlant works fine in a proxied environment. I think it looks at the, should say it correctly. I think it's the X forwarded 4 header, where what it looks at on the server side. So that's if you use redirectors. And in terms of the proxied environment, which I think you mean on the implant side. So if there's if you run the implant in a environment that uses a web proxy like Zscaler or whatever to control internet traffic, it also works. The library that NimPlant uses for HTTP traffic, which is called Puppy. It's quite a nice library in Nim that uses a proxy-aware agent by default. So basically, whatever the system uses as a proxy, NimPlant will use as well. So yeah, it should work in any proxied environment. I hope that answered the question. Any other questions that came in?
I think that's it, and we're somewhat out of time here. I don't want to keep you longer than we.
Yeah, no,
we meant to.
no worries.
I think we can call it.
Well,
thank you so much for coming out today. This has been a really fun talk. I'm glad we got a chance to give a closer look at NimPlant. Recommend everyone take it for a spin. It's actually really good, and even just as reference code, if you're looking to develop your own tooling in Nim, or you're curious to learn more about the Nim language through an offensive lens, the NimPlant code is pretty tight. I think this combined with Secure This Shit's material is basically all you need to get started. So thanks so much, Cas, for coming out today. It's been a pleasure, and hopefully we'll see you back soon.
Yeah, thanks so much. And maybe as closing words, indeed, what you said kind of hits the nail on the head. NimPlant was a project for learning, right? So I would definitely recommend everyone to pick up a project like this for learning, be it malware development or just learning new programming languages in general. I do also have some slides actually on interesting articles and people to follow as well. Again, Fabian, indeed, Shit Secure was here last week. If you missed his talk, definitely take a look at that because in terms of malware development, there's a lot of stuff there as well. You can find these slides and all the resources on my GitHub as well. So that said, thanks so much everyone for tuning in. And if you have any questions after the fact, you know where to find me. And have a nice afternoon or evening for now then.